This problem asks us about how slowly a blimp would have to move in order to keep the airflow around it laminar and not smooth. And we're told to assume the critical Reynolds number is equal to 2300, which is the number that Reynolds himself stated was the dividing line between laminar and turbulent flow. So the relative, the relative model that governs this is the Reynolds number model, which says the Reynolds number is equal to the density of the fluid times the obstacle length times the flow speed divided by the viscosity. And since we want to know a speed, the flow speed, the speed of the air moving past the blimp is what we want to calculate. So we want to isolate flow speed. In order to do that, you would multiply both sides of the equation by viscosity and divide both sides of the equation by density times obstacle length. The rewritten model looks like flow speed equals the Reynolds number times the viscosity divided by the product of density and obstacle length. Then we should be able to plug in. We're told to assume the Reynolds number is 2300. The viscosity of air, we need to look up. It's in the table that's in chapter 6, and it happens to be 0. Gotta get all these zeros in here, 0.0000183 Pascal seconds. So not an incredibly viscous fluid, which probably you know already. It's a lot easier to move through air than it is through water or almost any other sort of liquid that you can think of. The problem tells us that the density of air is 1.25 kilograms per cubic meter. And our blimp in this problem is 26 meters. Though if you solve this problem, very good chance that the computer is going to randomize the width of the blimp for you. So if we calculate that, I'm taking 2300 multiplied by 0.0000183 and dividing that by 1.25 and 26. And I'm guessing I'm going to get a very small number indeed. 0.001295. I don't know, you keep going there. What does that mean? Well, that's in meters per second. And there are 1,000 millimeters in a second. So this is the same thing as 1.295 millimeters every second, which might be a snail speed, but is not a blimp speed, even though blimps are not high-speed aircraft. So you'd have to move slower than that in order to keep the flow laminar around the blimp.